Chapter 22. Maintaining Air Quality. Part 1. Composition of Air. Clean, dry air is made up of 78% nitrogen by volume, 21% oxygen, 1% noble gases, mainly argon, and 0.03% carbon dioxide. Air can be separated into its components by fractional distillation. Air is cooled and compressed into a liquid and then gently warmed. The gas with the lowest boiling point, nitrogen, distills off first. Part 2. Pollutant gases. Sources and effects. In Part 2, we will look at the sources and effects of 3 common pollutant gases. They are carbon monoxide, sulfur dioxide, and oxides of nitrogen. Pollutant 1. Carbon monoxide. Source. Carbon monoxide is formed from the incomplete combustion of carbon-containing fuels. Effects. Carbon monoxide combines with hemoglobin in the blood and reduces the ability of hemoglobin to transport oxygen around the body. Pollutant 2. Sulfur dioxide. Source. Sulfur dioxide is formed when fossil fuels containing sulfur are burned in power stations and factories. Sulfur dioxide is also produced during volcanic eruptions. Effects. Sulfur dioxide irritates the eyes and lungs. Sulfur dioxide also reacts with water in the atmosphere to form acid rain, which damages buildings made of metal or limestone and reduces the pH of lakes and streams, which harms aquatic life. Pollutant 3. Oxides of nitrogen. Nitrogen monoxide and nitrogen dioxide. Source. Oxides of nitrogen are formed when nitrogen and oxygen undergo reactions at very high temperatures inside car engines. Oxides of nitrogen can also be formed by lightning activity. Oxides of nitrogen irritate the eyes and lungs. Oxides of nitrogen also react with water in the atmosphere to form acid rain, which damages buildings made of metal or limestone and reduces the pH of lakes and streams, which harms aquatic life. Other air pollutants include unburned hydrocarbons, methane, and ozone. Unburnt hydrocarbons are released in car exhaust fumes and chemical plants. Methane is produced when plant and animal matter decay. Ozone is formed when nitrogen oxides react with unburnt hydrocarbons in the presence of sunlight. Part 3. Reducing air pollution. In Part 3, we will look at the 3 methods for reducing air pollution. Method 1. Catalytic converters. Catalytic converters can reduce the emission of the pollutant gases of carbon monoxide, nitrogen monoxide, and unburnt hydrocarbons found in the exhaust gases by converting them into less harmful gases. In the presence of transition metal catalysts, carbon monoxide is oxidized by oxygen to form carbon dioxide. Nitrogen monoxide is reduced by carbon monoxide to form nitrogen gas. Unburnt hydrocarbons are oxidized to carbon dioxide and water. Method 2. Flue gas desulfurization. When power stations burn fossil fuels containing sulfur, the waste gases, also known as flue gases, contain sulfur dioxide. The flue gases are reacted with calcium carbonate to remove the sulfur dioxide before they are released into the environment. Sulfur dioxide is reacted with calcium carbonate to form calcium sulfite. Calcium sulfite is further oxidized to calcium sulfate. Method 3. Liming. Liming is the process of adding calcium carbonate to lakes and fields affected by acid rain. Calcium carbonate will react with the excess acids present to reduce the effects of acid rain. Part 4. Depletion of ozone layer. Ozone gas present in the atmosphere helps to filter harmful ultraviolet radiation from the sun. However, the ozone layer can be depleted with the use of chlorofluorocarbons, or CFCs. CFCs are molecules that contain carbon, fluorine, and chlorine atoms only. In the presence of ultraviolet radiation, chlorofluorocarbons produce reactive chlorine atoms which react with ozone molecules. Part 5. Greenhouse effect, carbon cycle, and global warming. The carbon cycle is a mechanism that maintains the level of carbon dioxide in the atmosphere. In the cycle, there are processes that produce carbon dioxide and processes that remove carbon dioxide. Processes which produce carbon dioxide include respiration and combustion of fuels. Processes which remove carbon dioxide include photosynthesis and ocean uptake. When the rate of production of carbon dioxide is equal to the rate of removal of carbon dioxide, the level of carbon dioxide in the atmosphere is maintained. Carbon dioxide is a gas that can trap infrared radiation emitted by the Earth, which warms the Earth. This phenomenon is called the greenhouse effect. Gases which trap radiation are called greenhouse gases. Other than carbon dioxide, other greenhouse gases include methane and water vapor. Over the years, due to large-scale deforestation and burning of fossil fuels, more carbon dioxide is added to the atmosphere than it is removed. The buildup of carbon dioxide leads to an overall increase in the Earth's average temperature. This is called global warming. Global warming can lead to the following effects. 1. Changes in rainfall patterns, which can lead to desertification of lands. 2. Heat waves. 3. Extreme weather, such as tropical storms. 4. Ocean warming and acidification, which harms marine organisms, mainly by dissolving their calcium carbonate shells and skeletons. 5. Glacial retreat and melting of polar caps. End of chapter 22.